Can you see my screen?
Yes.
Okay. So previous day we have seen how to install Conda and PyTorch. So anyone of you have problem in that? If you have problem, then you can tell us. We can try to solve this issue. First, you have to install the Conda, Anaconda. Then you have to create a virtual environment. Then you have try to install the PyTorch according to your environment, your system. So if you done that, already done that, so we can show you some operation done on the tensors. So we will show you all those operations in Google Colab. Okay. So what you have to do, you have to log into your Gmail account, and what you can do, you can write here Google Colab, and here you can open new notebook. Okay. New notebook, and it will forward you to a new notebook, right? So during coding, what you have to do, sometimes you have to access the drive, Google Drive, to get the data. Okay, so what you can do, you can click here, and from here it will take some time. So now here you can click this button, this to mount your drive. So connect to Google Drive. This way you can access your drive from this folder. From here, drive, and now come to my drive, and here you will take any folder or file, and here you can click and copy the path. This way you can access any files. Network. Now, today I will show you some operations on Torch. So first you have to import Torch. Similarly, this library is already installed in Colab, so you don't have to install this library. So if you try to run any terminal command here, so you have what you do, you have to write this and write pip install the library name, and it will be installed. Now I will show you some operations on tensors. So previous day already we have shown some operations. So what is the difference between NumPy and Torch? In NumPy, it is a you cannot use GPU in NumPy. Okay, so that's why Torch is handy here. So, but you can easily convert the NumPy array to Torch tensors, or you can convert Torch tensors to NumPy. How to do that? For example, let's say first I am importing NumPy. Then a equal to dot import NumPy as np. Then run the command. So now if you print a is a NumPy array. Now if you write p equal to torch dot on numpy in now you can see that it is a type tensor. Fine. So similarly you can also convert these tensors, torch tensors to numpy. How to do that? In that case, a function is numpy. It is from numpy. Let's see. It's from C equal to B dot numpy. And now you can see it will again give you numpy again. Now, as we are using a torch, so we can use GPU here in this collab. So to check whether GPU is available or not, we can write this command torch dot dot is available. Is false. So in that case, you have to first go to runtime, and here you have to change the runtime to GPU. Okay. Now you have to okay, this is not this one. Oops. Now if I check so after mounting the so again I have to restart the runtime. Yes. Now if I check whether the CUDA is available or not, you can see it will be available. Now it is true. That means now CUDA is available. Fine. So to convert this these tensors to the GPU version, what you have to do to write device equal to torch dot device. Here you can write now there are many options how to convert these tensors to GPU version. One is you can write, so for example, y equal to torch. So I'm creating one. If you this x is not available, I can write, let's say any variable, but which one is tensor? In that case, B. Is not defined. Okay, so I have to write here. I have to write this. This one. Another way, what you can do is B equal to B dot to device. This is another way you can convert this CPU tensors to GPU tensors. Okay, to convert these tensors to in the CPU version, what you have to do, you just write B equal to B equal to, you can do what, B dot CPU. This way you can use this CPU and GPU conversion. But what you have to check that whether you are doing any operations, all these tensors should be in CPU or in GPU. Else you will get some error. Now in our any deep learning model, the one important thing is gradient calculation. Okay, so each time you have to calculate the gradient of each variable. It is very important in case of training. So PyTorch gives you a facility to calculate the gradient. It will itself calculate the gradient. You don't have to explicitly do it. So here it will do that using the AutoGrad package. For example, let's say I am defining a new tensor, torch dot dimensional variable. So if you do that, you will check now. It's here the calculate to if you want to explicitly you have to mention the required grad equal to true to track all the gradient information of this variable x. Else by default it is false. So what you have to do x equal to torch dot and n. Now you have to explicitly write grad equal to, by default it is false. So now if you check, you can see that requires grad equal to true. So you have, if you want to calculate the gradient, what you can do, you can use another variable while x plus 2, then print x, print y, we can print y dot can use more complex operations like z equal to y star y star print z equal to. Okay, I'm just adding some more operations here. Now, if you want to calculate the partial derivative of z with respect to x, so that means if you want to calculate the dz by dx, what you have to do is write z term backwards. That point x dot grad, here you will get the value. In case if you want that,
X dot grad gives me what?
this is the value of dz dx. The change of uh, value of z with respect to x. This one.
Okay, then how will I calculate dz dy? Y dot grad.
So in that case, it may give error. But checking. So if you write here y, you are saying is warning the grad active of a tensor that is not a leaf tensor is being exercised a grad active one of the top given. Written grad. Written grad. I will check it. I have to check, okay. This thing I have to check.
Okay.
I think if you want that you don't want to calculate the gradient, so in that case you can use one option is that you can use here require grad equal to false during the tensor definition declaration, or you can use another function that is with no grad. Dot now you can see that the gradient calculation is activated. This way you can, these are the few operations useful during your deep learning model coding. And I think the view and reshape operations already covered. There are other operations which, for example, so these are the basic operations. There are other operations like squeeze, unsqueeze, and view and reshape. Those operations are used for changing, manipulating the tensor dimensions. For example, if you now, if you want to increase the dimension of this tensor, what you can do to so based on the index you can increase. If you if you zero, so in the zeroth dimension will be increased by 1. So now you can see tensor not end. Input must be tensor. It is a something like b equal to a comma 0. Now you can see b dot shape. You can see that the shape of b is increased by 1. So if you write here 2, in that case, this now the dimension increase here. Now, if you want to reduce the dimension, in that case, you have to use squeeze operation. For example, C dot now you can write B check. Even if you don't have to write this operation because it will squeeze where the dimension is one. You can see that in that case also it is the dimension reduced. Another thing is a reshape operation. Reshape operation is similar to view operation. So torch dot
Hi, Alapan.
yes, yes.
I'm sorry to interrupt you, but
Yes.
I have a small doubt. On
Yes.
line number 41, you have written b equals to torch.ansqueeze a comma 2. Can you please tell me just what does that 2 signify?
2 is the dimension where you want to increase your dimension. So this one is 0, this one is 1. So the dimension will increase here.
Okay, so 2 is basically the index.
Index.
Okay, thank you.
So equal torch dot reset. Here you can.
Suppose one thing. Suppose at the index 2, I want the dimension to be 3. Then what will I do?
Here you want to 3.
Yes.
You cannot. It is just increasing the dimension size. If you have to use 3, in that case, 3 means
3 means this will be the size of the tensor is 2 cross 2 cross 3 cross 3, and I want the 3 to be exactly at the second index. I mean third index.
2 to 3, 3.
Yes.
So I think in that case you have to use a repeat function. Check. What it will do if you write the tensor of size 1, 2, 3. No, it will not do. 4, 2. 4, 2, what will do? 3. Expand times the repeat dimension. So what you can do? So this 2, 3, 3. So first you have to unsqueeze in a, 2. Now it will be of size 2, 2, 1, 3. And then what we can do? Code b equal to torch dot b dot repeat. You try to use repeat function. The repeat function will do this one. So b, you explore this repeat function, this will increase the function. What it will do? It will copy the same tensor again 3 times. If you let's say if it is 2, 2, 3. Now you squeeze this if you now print A, it is this one. Now I am printing B. So it is just increase a dimension. Fine. So now if you try, if you tell that 2 3 comma 2, so there is another value required to increase the dimension of print B dot say. Now it is increased by 1 because your dimension is increased by 1, but you cannot write it 2 comma 3 comma 2, right? 2 2 comma 3 comma 2, if you change to the shape to 2 comma 3 comma 2, then you need another value. That's why you have to use repeat function. That will, what it will do, it will create another copy of this value and keep it here. So there is another function. It is a reshape function. What it will do, it will manipulate the size. For example, it is now the size of B equal to 2.3.1. What you can do, dot reshape B comma 2 comma 2. Now if you can see, yes, you can see the dimension change. There is another function called permute.
Sir,
Yes.
sir, once can you go to the backward function where you explain? I'm getting error when I'm running it. Yes, sir. Like after here I did the same y equal to x plus 2, and after that when I'm printing y dot backward, it is giving some error.
Y equal to x plus 2. Then
Y dot backward.
it is giving error. What
Yes,
is
sir.
error?
So it is saying grad can be implicitly created only for scalar outputs.
Okay, what you can do this, because this in the backward function where you have called this y dot backward, in the bracket you write x. Then
It is
check.
working.
Actually, what happened basically, during this value on which you are calling this backward function, it should be a scalar. Okay, and when it is a tensor, in that case the parameter is also a tensor, because this z, it is a scalar value, because I have calculated this mean. Okay, it is one dimensional, not scalar, it's one dimensional. That's why you don't have to give any parameter.
Okay, sir.
If it is a tensor of size more than 1, then in that case you have to give the parameter on which you are calculating the gradient. Another thing, you can use this torch dot.
Sir, for Z, it is giving the error even when I'm passing X also.
Hmm?
I wrote Z equal to Z dot main, and after that Z dot backward of X. It is giving error. Even without X also.
The error, you read the error.
Sir,
Read the error message.
without the X, it is giving some runtime error. Trying to backward through the graph a second time, or directly access saved tensors after they have already been freed. Specify and retain graph equal to true if you need backward through the graph a second time, or if you need to access saved tensors after calling backward.
Okay, in the next class we will try to elaborate this gradient thing. Okay.
Okay. Sir.
Next class we will. There is another function permute. It is also used to change the dimensions. For example, let's say the function torch dot c dot b set the shape of the tensor b is 2, 3, 1. So if you do torch dot b comma, just give the dimension indexes by how you want to manipulate these dimensions. So I'm write 1, 0, 2. So dimension of b is 2, 3, 1. Now the dimension of this variable of this tensor d will be 3, 2, 1. So this indexes are changed. These are the few operations on tensors which will be useful in deep learning coding. So in the next class we will show you how the gradient is calculated and these autograd functions in more details, and we will implement the back propagation. That's all for today. So tomorrow you have a quiz. It is based on linear algebra. Please attend tomorrow's quiz.